Hi everyone, I hope you're doing well and the week of remote learning and week 1 of remote learning I should say is going well for you all. What I wanted to do is put some time into setting up a way that I can communicate with you a little better and post some videos. So what I've done here is I've taken my document camera, I have it right here just pointing at a sheet of paper. I have a webcam looking right at me. It's kind of awkward, but that's okay. We'll go with it. And at the same time, I have this fancy setup. I feel so official where I can flip between my computer screen and the document camera just to help make things a little more streamlined. So the goal of this is to really give you some closure in the practice that we're doing this week and what I'm asking you to do rather than just saying, oh, you have it, or trying to suggest comments. So the plan is I'm going to take some time right now to talk through how to plot a trig function and then work through the first problem that we were assigned. And then after that, shortly after that, I'll upload a second video working through the second problem. I'm going to plan on doing this every Friday just so you can kind of be in a place where you know what you may need to adjust. As I've said a lot, be patient with this process. We are still learning and working out the kinks, and your teachers as well are learning at the same time how to best suit your needs and make this a process that everyone's successful in. So what we're going to do is I'm going to take a moment just to walk through how we graph a sine function and what that looks like. I approach it in a way that I plot 5 key points which directly relate to different positions on the unit circle. I think this will be helpful after what I've seen with some of the assignments that have been turned in. They look like we're in a good place, but I think that we can fine tune and brush up on this a little bit so it makes a little more sense for everyone. So what I'm going to do is just look at a unit circle first. So questions I've been getting via private messages and just the process and work we've done this week so far is what are we actually plotting when you're asked to graph a sine function or a cosine function. So if you remember about 3 weeks ago in class we were looking at this and we talked about how the cosine of a point on the unit circle is the x value. It represents the horizontal distance this point is from the origin. So like pi sixth is root 3 over 2 away from the origin in the horizontal direction. Something like pi halves is 0 units away from the origin horizontally. But what we're looking at in this specific problem, number 1, is sine. So sine is the y value. That represents the vertical distance above the y-axis. So what we're looking at in all of these is how high the point, which is on the unit circle, is from the x-axis, basically. So like we'd say sine of pi sixth, or 30 degrees, in this case we're working in radians, is 1/2, meaning this is 1/2 of a unit up from the x-axis. So when we look at a sine function, I'm just going to pull up Desmos real quick here. When we look at a sine function, there's a few features that are of interest to us. Doesn't matter if that's in parentheses or not. The first is that this sine function we say is bounded between +1 and -1. If I go to any point here, the highest point, this is called a maximum value, is 1. It doesn't matter which direction I go. If I'm going counterclockwise or if I'm going clockwise, here I'm at 9 pi halves and it's still 1. So we can say this is bounded by y equals 1. So this is the upper bound, we say. And then there's a lower bound at y equals -1. So it never goes below -1. It never goes above +1. This is a standard sine function, which we base all the other graphs off of when we begin transforming it. And this makes total sense if we go back to the unit circle, because if we look at this circle, well, the highest point this circle is right here at pi halves, and it's 1 unit above the x-axis. The lowest point is 3 pi halves, and that's 1 unit below the x-axis. So as we make our way around this circle, we're just plotting basically how high it is above the x-axis, and we see that this is the local, or a maximum. It's not a local max, it's a maximum point, because we know it doesn't go above that. Always, we just keep hitting this every time. So we would actually say this oscillates between +1 and -1 as we plot points around the unit circle. So we're going to use this to our advantage, in that as we transform points on this, like here, this changes the amplitude is what we talked about, and we'll get into that. Now it's going to be 3 units above. So if I change this to a 3, all of a sudden the upper bound is 3. So it oscillates now between +3 and -3. So we're going to use this to our advantage, as I said. The second thing we're interested in is actually, let's go back. I want this just to be regular sine. What we're interested in is when it hits 0. In this case, this is called the principal axis. Actually, it's always called the principal axis because we have plus 0. In this case, there's a plus 0 on this sine function. So at y equals 0, this is what the function oscillates through as well, but this is called our principal axis. So we're interested in actually 5 points. We're interested in where it starts, which is always at the principal axis. We're interested in when it hits a maximum. We're interested in when it hits the principal axis again. We're interested in when it hits a minimum. And then one full cycle, or period we call it, is when it resets and we make it all the way around the circle and plotting points. So here, 2 pi is a point. I'm going to clean out everything else here. Oh my goodness, there's a ton of points. If we get rid of all of these points, 2 pi and 0, this is one full rotation. So we'd call this a period, one full revolution around the circle of plotting. So we see that 0 all the way around 2 pi, it just resets. So as we go through to 4 pi, we're just going around the circle again, which is why we see this sort of oscillation going on over and over and over. It just repeats the same points over and over again. So when we're plotting this function, what we're interested in, like I mentioned, is when it starts. When it's a quarter of the way through the rotation, it actually hits a maximum, because if I start working around this circle, I've gone a quarter of the way around the circle, and I'm at the highest point this circle is. So always when it's a quarter of the way through its rotation, which we call a period, if I go all the way around 2 pi, that's called 1 period. As we're a quarter of the way through a period, it hits a maximum. Then when we're halfway through the period, it's back on the principal axis. When we're 3/4 of the way through, I've gone 3/4 of the way around the circle, all I have left is a fourth, it's actually always going to be at a minimum. Then as I go one full period, or one full rotation or revolution around the unit circle, it's back at the principal axis and its starting value. And then it just repeats that process over and over and over as it oscillates, we say. So what we're going to do is let's go ahead and let's plot this. So y equals 3 sine x minus 2. We'll worry about the from 0 to 4 pi radians in just a moment here. But as we plot this, first thing we're going to need is a axis. So I know that this graph is actually going to be shifted down because of the minus 2. So I'm going to make this have more positive values in its range than have more negative values in its range than positive. So here's x, here's y. Ultimately, we're going to want to go 4 pi here. But right now, we're only worried about 1 period. And because this value inside that the sine's being applied to is just 1, it's 1x there, we don't have to worry about the period changing yet. That's next week when we start changing that. That's called the b value. So what we want right now is just to graph 1 period. So 1 period would be 2 pi. And then let's just set up a little bit on our y-axis. So normally my principal axis is here at 0, but what we've done here, now let's start looking at what's happening to this function. This minus 2, what we're doing is we're taking the function sine x, which happens to be multiplied by 3, and we're subtracting 2 from it. This is no different than taking x squared minus 2, or x minus 2, or square root of x minus 2, with that minus 2 outside of the radical. So what it's doing is it's transforming the function down 2 units. So I know 2 units down is my principal axis. I always like plotting this, so I'm going to use a different color just to put a dashed horizontal line indicating where that principal axis is at all times, because this is going to be one of 3 of my 5 points actually, is when it hits the principal axis is what I'm interested in. So now I'm going to plot the maximum value. So as you should have noticed in the Desmos activities and your discussions and whatever source you chose to learn from, this 3 changes what we call the amplitude, which is how high it is above and below the principal axis. It's basically vertically stretching. Well, it is vertically stretching our trig function. So instead of being 1 unit above, which is what we normally see, so right here in the sine function, we just see a 1. There's 1 there. We just don't write it. When we change it to a 3, it changes that amplitude now to being 3 units above the principal axis. So I need to mark 3 units above -2. So 1, 2, 3, positive 1. And I'm going to put another dashed line here, because this indicates the maximum. I never want to go above this dashed line. It's just going to just be a guide for how I plot this. Finally, 3 units below -2, 1, 2, 3, -3, -4, -5. So this function is never going to reach a value below -5. It will hit -5. It'll hit -5 a lot if we plot it enough, but for our sake, it's never going to go below that value. So here we have it. This is my principal axis. This is the max, this is the min, and now we'll go on our way as to deciding what a half a period is going to be, what a quarter of a period is going to be. So in this case, we said, just like on a standard unit circle, 2 pi radians gets me all the way around the unit circle. So that's 1 period, we say. So at 2 pi, I know I'm going to be 1 period away. So what I want to think about is what's half of that. So half of 2 pi is just 1 pi, or pi. So that's going to be halfway through the period. And then I want to go half of this distance as well. So between 0 and 1 is pi halves. And then between 1 pi and 2 pi is 1.5 pi, or 3 pi halves. So we're set now. We have 1, 2, 3, 4, 5 points where it's going to hit different values, or it's going to reach different values. So as we said, at 0 radians is where I'm starting my revolution or my period. It's at the principal axis of -2. Now, a quarter of the way through, it's going to be at the highest point on the unit circle, no matter what our circle looks like or our function. So I know the highest point already is 1. So at pi halves, a quarter of the way through our period, it's at a maximum. Halfway, it's at the principal axis. 3/4 of the way through our rotation, again, 3/4 of the way around a unit circle, there's 1/4. There's 2/4, or a half. There's 3/4. Right here, it's at a minimum value. So we want to plot that accordingly. And we've already set up what that minimum value is. It's -5. So 3/4, and then back at 2 pi, it's where it started. So we can fit a curve onto this now. If we wanted to be really precise, we could add, whoa, that's steep, but oh well. We could add like pi eighths. We could add 1/8 of the way through. We could start plotting more specific values, but this is just a general idea of what it looks like, and this will do the trick for us here. So now we need to do the same thing from 2 pi to 4 pi. All we're doing is we're saying, well, we've gone 1 period around the circle. Now we're going to do another one and do the exact same thing. So basically, we're just going to add 2 pi to every value, or we can just work through this and think through, well, if I'm going from 2 pi to 4 pi, halfway between 2 and 4 is 3. So halfway here is 3 pi. And now, if I think of this in terms of halves, because I'm going to take half of this value, 2 pi is actually 4 pi over 2. 3 pi is 6 pi over 2. So that means in between 4 and 6, I have 5 pi over 2, which doesn't reduce. Now, same thing here, 6 pi over 2, 8 pi over 2. Halfway between 6 and 8 is 7. So I have 7 pi halves. Again, that one didn't reduce, so we'll leave it as such. Now we have our 1, 2, 3, 4, 5 points we're interested in. We already have the first one plotted. This is starting our second period around the unit circle. At 1/4 of the way, it's at a maximum. Halfway, it's back at the principal axis. 3/4 of the way, it's at a minimum. Now back at our rotation, we've made 1 full period, another one for 2. We're back on the principal axis. So now we go ahead with a curve and we plot this. Again, it's early, I guess. I haven't had enough coffee. My lines are a little funky, but that's okay. Or my curves, I should say, are a little funky. So that's how we can plot 3 sine x minus 2. Everything really goes back to the unit circle, which is why we spent a lot of time in this leading up to, I guess, our remote learning transition. So I hope this video helped. Look for the second video coming tomorrow, or if you're watching this on Friday or any other time, it should be posted already. Again, continue to communicate with me. Reach out to your classmates if you have questions, or reach out to myself. I'm always open. I'll be around. We'll keep in touch. Hopefully, we'll talk to you soon.